Hi, my name is Kathryn Gonzalez,
And I'm Rachel Richard.
and today we are going to be talking about Pascal's principles and hydraulic pumps.
In this video, you will learn who Pascal is, what Pascal's principle states, how Pascal's principle is used in hydraulic pumps, and we will even show some examples using equations stated in Pascal's principle.
Blaise Pascal was a French mathematician and physicist. He is known for inventing the hydraulic press and syringe. He is also known for Pascal's barrel experiment. In this experiment, Pascal supposedly inserted a long vertical tube into a barrel filled with water. When the water was poured into the vertical tube, the increase in hydrostatic pressure caused the barrel to burst. As you can see, the pressure with the top thin tube filled with water is almost 40 times that of the pressure on barrel without the top thin tube.
Pascal's principle is also known as Pascal's law or the principle of transmission of fluid pressure. This law works because, in an incompressible fluid, the pressure remains the same throughout the entire fluid. A pressure change occurring anywhere in a confined incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere. Because of this, a small force applied to a small area translates to a large force over a large area.
Hydraulic pumps are a machine press that uses a hydraulic cylinder to generate a compressive force. Examples of hydraulic pumps include barber's chairs, theater stages, car jacks, and office chairs. The pump that the barber steps on uses a hydraulic lift mechanism to adjust the chair's height accordingly. Hydraulics make it possible for the office chair to rise up or go down, or lean backwards or forwards as you adjust its corresponding levers. A hydraulic system in a car jack is what makes it possible for a very heavy car to be raised and brought down while being serviced.
The main equations to consider when using Pascal's law are that the pressure at any one point in the fluid is equal to the pressure at any other point in the fluid. This also translates to force 2 over force 1 equals area 2 over area 1, or force 1 over area 1 is equal to force 2 over area 2. In this problem, we are looking to find the small force applied over the small area of 1 inch squared. We are given that the large area is 50 inches squared and the large force applied on the car is 400 pounds. We can rearrange the formula that we were given earlier to be the small force is equal to the large force times the small area divided by the large area. When we do this calculation, we find that only 8 pounds of force are needed to raise this 400-pound car.
In this problem, instead of solving for force 1, we are solving for area 2 or the larger area. We are given that force 1 is equal to 30 pounds, area 1 is equal to 2 inches squared, and force 2 is equal to 2,000 pounds. We are given the equation force 2 over force 1 is equal to area 2 over area 1. If we rearrange the equation, we will get area 1 times force 2 over force 1 is equal to area 2. From here we can plug in our numbers. 2 inches squared times 2,000 pounds divided by 30 pounds is equal to 133.33 inches squared, which is our area 2 or larger area. In conclusion, Blaise Pascal was a French physicist who is known for Pascal's principle, which states that a pressure change occurring anywhere in a confined incompressible fluid is transmitted throughout the fluid such that the same change occurs everywhere. In the video, we gave you a couple of examples of how you can find hydraulic pumps in everyday things, like the barber's chair, office chairs, car jacks, or even on stages. In the examples, we showed you how to calculate the missing force and area from each problem.
We hope you learned something.
Thanks for watching.